Well, hello again, and I still wish that you are well and healthy in this crazy time that we are going through. This video is a test review. We have finished sections 9 and 10 on circles part 1 and part 2. This is a review. The review, the review that I'm going over now will actually be included with the video for your reference, and you will complete this as the warm-up um, for the day. This would help you to complete the test successfully. So let's get started so I don't make this video long. All right, so question number 1, it says quadrilateral WXYZ is inscribed in circle F. Write an equation that will allow you to solve for the measure of 4. So let's take a look here. Will allow you to solve for the measure of 4. Now, in a quadrilateral, the one thing that you all know is the sum of all angles is equal to 360. So this could be your first um, um, thought, I would say, equal to 360. So for me to find the measure of 4 alone, I can just say that if I know the measure of 1, 2, and 3, can I just subtract them all from 360? The answer is yes. So your first thought or process would be to find the measure 4, you would subtract 360 degrees minus the measure of 1 plus the measure of 2 plus the measure of 3. That's one way. Now, but the quadrilateral is inscribed in a circle. We have learned that if the quadrilateral is inscribed in a circle, then the opposite angles in the circle are supplementary. This means the measure of 4 plus the measure of 2 is equal to 180. So we can say opposite angles here are supplementary. This means angle 2 and angle 4 are equal to 180. Angle 1 and angle 3 are equal to 180. So I can say that the measure of angle 2 plus the measure of angle 4 equal to 180. And that's really what I'm looking for, but I'm solving for 4. So if I subtract the measure of 2 from both sides, I would get measure of 4 equal, it will go away here, and I'll have 180 minus the measure of 2. And this would be the ideal answer to that question because this quadrilateral is really inscribed in the circle. Okay? All right. Moving to question number 2. The question says, given the circle Q, find the value of x. And please read each of those questions carefully. A big part of answering the test is to read the questions. So let's talk about this and again, I highly recommend to watch the circles review video before this. I think it was a 10-minute video, so it wouldn't be long, but it would be nice to watch. All right, so let's take a look. So we have an arc right here, and we also have an angle. We have two angles that share the same arc. We have the angle that's labeled 6x minus 11. We have the angle that's labeled 8x plus 18. Both of these angles, they do share the arc that I bolded in maroon. So the question here, the inscribed, this is right there is an inscribed angle. If you can label them, so this is inscribed. This angle right there is a central angle. The inscribed angle is equal to 1/2 of the arc. The central is actually equal to the arc. So I can say that the inscribed has a relationship with the central by saying the inscribed is actually 1/2 of the central. So the inscribed angle is equal to 1/2 of the central angle. All right, now we are looking to find x. Remember that. So the inscribed is 6x minus 11. 6x minus 11 equal to 1/2. The central is 8x plus 18. 8x plus 18. And that's it. We just solved for x. And the question didn't ask for anything more than that. So before I would multiply the 1/2. 1/2 times 8, that's 4x. 1/2 times 18, that is 9. Subtract 4x from both sides. So 6x minus 2 minus 4 is 2x. Add the 11 to both sides. 9 plus 11 is 20. Divide the 2. X is equal to 10. Did the question ask for anything different? So please remember, when you are solving here, the inscribed angle is not equal to the central. It's half of the central angle. Okay, again, it's half of the central, not equal to the actual center angle. All right, moving to question 3. It says find the center and the radius of the circle defined by the equation below. For me to find the center of the radius, the center and the radius, I have to remember what was the standard form of the equation of a circle. And let's remember that. So it is I didn't mean to use the highlighter. So it's x minus h squared plus y minus k squared equal to r squared. I'm really hoping that you remember. The h and k serve as the, yes, center of the circle. R is the radius of the circle. So again, this is the radius of the circle. K and H are the center of the central of the circle. The question is asking to find the center, which mean H and K, and asking to find the radius, which mean R. So for me to do that, I really have to look at the equation that's given to me. Well, the equation is not given in standard form. The equation given in a general form, which means that you have to convert between the general form to the standard form to find the center and the radius. Now, how do I do that? We do it with a process that's called completing the square. And we learned this in school, and I said you have to move the 11 in first. So first move the 11. Sorry, nope, we don't need to move the 11. We have to move it back. All right, sorry, disregard that. We don't need to move the 11. We have to group the x and the y. So we have to group the x and group the y. We will rewrite the x and the y, leaving space. So it's going to be x squared minus 4x plus nothing. That's our magic number. We have to keep the space. Plus, that's where the x is. Now we're going to group the y and do the same thing. Y squared minus 6y plus a space for your magic number equal to 11. Remember, we added 2 free spaces on the left side of the equation. We must add 2 free spaces on the right side of the equation as well. What you do to the left, you do to the right to keep the equation balanced all the time. Now, next thing is we're going to draw the boxes. Now, I'm totally fine with the students who like to do it with the other method. You guys free to do however you want to, but this has been proven that it is the best way for students to learn it. All right, so x squared, the x squared will go here, and the y will go here. The process is the same whether you're completing the square for x or for y. All right, 4x has to be divided here, so you get negative 2x and you get negative 2x. Please keep in your mind your signs. Negative 6y, we have to split that in half, so that would be 3y and negative 3y. Now again, where does that come from? We split 6. We divide the 6 by 2. We divide the 4 by 2. Now, your magic number, really what goes, it's really what goes here. So the magic number is really these two numbers together here, negative 2 times negative 2 is 4. Negative 3 times negative 3 is positive 9. Your magic number is always positive. So 4 will go to here and again here. The 9 will go here and again here. Why are we adding it to both sides? Because we can't change the actual equation. Now we do something called a factoring process. We look at the vertical line here, vertical boxes and the horizontal boxes, and we make sure that we factor up and going across and going up. So x squared and negative 2x, whatever in common is just x. Negative 2x and 4, whatever in common is negative 2. And then if you look across, it's going to be the same. X squared, negative 2x, and 4 would be negative 2. These two must be exactly the same. If they are not, you have done something wrong. They must be exactly the same. That's really the whole process of completing the square. Now, we do the same thing for y. So between y squared and negative 3y is y. Negative 3y and 9 is negative 3. Same thing if you do it across. And again, and again, and again. These must be the same factor. If they are not, you've done something wrong. Now, that's how I completed the square on this side. Now, this whole thing should equal to the sum of 11 plus 4 plus 9. So 11 plus 4 is 15. 15 plus 9 is 24. Now, let's look at all of this and write the standard form of a circle. So we have x minus 2 and x minus 2. Can we just keep one and put a square on the top? We don't need to write both of them. Plus y minus 3, y minus 3. Can we keep one and put a square on the top? And equal to 24. Where did that number come from? It's actually the addition of 11 plus 4 plus 9. That's the general form of a, sorry, not the general, the standard form of a circle. Now, the question didn't ask us to write the standard form. The question asked us to write the center and the radius. So I'm just going to write the center and radius on the side. So center would be 2 and 3. Remember to flip your signs as you go outside. Your signs must always be flipped of h and k, because that negative has to stay with the formula. You only take the number out. We don't take the negative with it. The radius, it's not 24. It's actually the square root of 24. The square root of 24. You can find it in decimal if you want to, but I'm just going to leave it in radical. There really no need to do it harder than that. We just leave it this way, and that would be our answer. If you're having trouble with completing the square after I showed here, you may want to watch the Khan Academy, finding in the center of a radius, using the general form to convert to standard form. They do it the algebraic way, and it might be easier than the area method, but you can actually Google that. I can attach the link with this video for those who want it. All right, next question is, based on the diagram below, what is the measure of arc AB? What's the measure of arc AB? So I'm looking at this arc right there. Now, if you have watched the video again on summarizing all equations of circles, you'll see that there was one of them that says if we have two chords intersect inside a circle, then the angle that's formed between the chord is actually equal to 1/2 of the sum of the arc. I can write it here. So the angle is equal to 1/2 of arc 1 plus arc 2. Now, which angle is it? Is it the 120 or is it this one? Now, the angle must face the arc. The 120 doesn't face arc AB or arc CD. So we can't really use the 120. We have to use this angle right here. Well, how do I find it? Well, if you remember back in chapter, I think it was section 1, when we talked about linear pair, we said that if the two lines are on the two angles are on the same line, they form a straight angle. Therefore, they will be linear. So both of these together is 180. Just for me to find this by itself, then it would be 180 minus 120, which is 60 degree. So the angle right here is really 60 degree. Now again, where did the 60 degree come from? Well, the 60 degree is 180 minus 120 because both of these angles are on the same line. And then we can use a 60. So 60 equal 1/2. Well, arc 1 is 4x plus minus 11 plus arc 2 is 5x minus 4. Please remember, it doesn't matter which arc is which in this case because we're adding both of the arcs. So whether we put the 5x minus 4 first, then the 4x minus 11, it really wouldn't make a difference. All right, now 60 degrees. I would highly recommend that you first combine what's inside your parentheses before distributing the 1/2. Might make it easier. So 4 plus 5 is 9x. Negative 11 minus 4 is negative 15. Now we distribute the 1/2. So we get 60 degrees equal 1/2 times 9 is 4.5x. 1/2 times negative 15 is negative 7.5. And now we solve. We add the 7.5 to both sides. This goes away. So we get 67.5 equal 44.5x. We divide the 4.5. 67.5 divided by 4.5 is equal to 15. So x here is 15. Now, are you done? No, you're not, because the question was asking for arc AB. So we have to plug it in here. So to find the measure of arc AB, I would find a measure of AB equal to 5 times 15 minus 4. 5 times 15 minus 4 is 71 degrees. So your answer is 71. So again, this is not a one-step problem. This is a three-step problem. Number one is you're going to find the angle that you're using first by subtracting the given angle from 180. Step two is use this form right there. The arc angle is equal to 1/2 of both of the arcs. Once you find x, you plug it in, and that's step 3 to find the missing arc. All right, question number 5. In circle Z as pictures below, not above, segment EF is tangent. And again, the word tangent mean 90-degree angle. So EF is tangent to circle Z, so that means the radius of the circle and the line that's touching the circle is making a 90-degree angle. Also, EF is 45, GE is 25. Find the length of the radius. So just to highlight what the radius is the distance between G to F and also the distance from Z to G. So I'm going to label this R and label that one also R. Now, this is a right triangle, so I can use Pythagorean. C squared is equal to a squared plus b squared. So what's c? So c is the hypotenuse. It's the distance from z to e. Well, ze is g and ge. So I can say that z to e is r plus 25. Is r plus 25. That's c. A squared is z to f, which is just r squared. B squared is the distance from F to E, which is 45. and then we solve this. Now, some of you will come across this right here now. We'll come across this right here and say, oh, Miss, how do we do this? Now, let me show you right down the side. How do we factor r plus 25 squared? Well, you create a square or a rectangle. R plus 25 squared is r plus 25 and r plus 25. Multiply r times r is r squared. 25 times r is 25r. 25 times 25 is 625. Let me just make it bigger so everybody can see it. $625. And okay, and then what did we say? And then 25 times 25, and then 25 r times 25. These right here must be exactly the same. So that would be 20. Okay, so I'll show it to you again because I know that looks pretty messy. All right, so first you create a rectangle. Now the R25 is the same as R plus 25 times R plus 25. So this right here we write R plus 25, and here we put R plus 25. Now I'm going to use a highlighter instead of the arrows because it's very unclear. We have to multiply R times R, then that R times 25. Then we, so here's what we do. R times R is R squared, that goes here. And then R times 25 is 25R. Now we do the same thing with the 25. We multiply the 25 times R. So 25 times R. And then 25 times 25. So 25 times R is 25R. And 25 times 25 would be 625. We combine these together, so we get R squared plus 25R plus 25R is 50R plus 625. That's it. That's what goes here. So R squared plus 50R plus 625 equal to R squared plus, scoot this, 45 squared should be 2025. All right, now you probably can see that these R's will cancel. We would subtract the 625 from both sides. So 50R equal to 1400. When we subtract these, we get 1400. We divide the 50. So R is 1400 divided by 50. I get 28. And units. So is this the radius of the circle? It is. All right, that was I'm going to stop here. This is part 1 of your video. I'm going to record part 2 and post that as well, but I didn't want to make this as lengthy so you don't get bored of listening to me all the time. So I'm going to go ahead and stop sharing my screen, and please look after for the part 2 video of that lesson. And again, until I see you next, please stay well and healthy.